how to get the expected frequency from a table like this, how to get the obtain chi-square, and how to get the p-value from this table. All right, so we're going to go back to the number 1. All right, so first what you want to do is you copy and paste this table right here. You just copy, copy and paste. You know how to do that. All right, just copy the paste into the table right onto the Excel, and there it is right here. Now what you want to do is see you want to get depressed and urban. You know, between depressed and urban, it's 120. Well, the expected frequency of that is going to be right here, the total of the row 310 and the total of the column 720 times each other, and you divide it by the total row right here. All right, so like 720 plus 390 plus 500 equals this, and 120 and 600 equals 7. You know, you see how it is. This row leads to urban depressed, and then this row leads to urban depressed. You multiply these two, and then you divide by here, and you get, and these are all the expected frequencies of each category right here. So right now, that's how you get the expected value. So right now, I'm going to teach you how to obtain the p-square now, the p-value of the chi-square test, all right? So what you're going to do, right, is you type in equals, here, I'll do it right here. Type in equals, CHI, and chi-square test right here. And then you hit FX, you hit actual range, which is right here. You highlight all this, don't get the totals, do not get the totals. You highlight that, you insert that. Expected range, and you highlight all the expected frequencies that I just taught you how to get. You say okay, and that's how you get the p-value. Now, of the actual chi-square, this is how you do it. You hit equals, CHI, you go to C, right here, invert RT. You hit invert RT, you hit FX. All right, probability, that's the p-value. You just click this, click the p-value, right here. And then degrees of freedom, here's how it's gonna be, all right? So row, wait. So this is a row. So depressed and non-depressed, that's 2 rows, and this is a column. That's 3 columns, 1, 2, 3. So what you're gonna do is the number of the rows, which is 2 minus 1, close that in, hit the time symbol, right? Starting another parentheses. And then you're gonna do, there's 3 columns like I showed you before. So you're gonna be 3 minus 1, and there, that's 2. It will equal to 2, and you hit okay. And that's how you get the chi-square test. That's the chi-square answer right there. So this is how you'll be doing a question like number 4, right? So it wants you to use the independence at alpha, which is 0.01. That's basically gonna be your substitute for the p-value, but you're going to use it to get the critical value of the chi-square, right? So here's the answer right here. So basically, you already have the p-value, right? Which is alpha, which is 0.01. So you're trying to get the critical chi-square, and it's going to do equals chi, and it's going to be chi, right here, this one, invert RT, and you're going to hit FX. Probability is going to be right here. This is exactly how you do get the chi-square from the other one, but you're using alpha as the p-value. Enter. Degrees of freedom, as we did it before, it was 2. Well, you know how it was. It was, what's it called? Here, I'll do it for you again. It was the rows, which is 2 minus 1, and you multiply that by the columns, which is 3 columns minus 1, and which is, yeah, the answer is 2. And you hit calculate, boom. Yeah, that's the critical chi-value, chi-square, whatever, you know. And you go to this question right here. It says, because the obtained chi-square is less than the critical value of the critical value of the chi-square. So here's the obtained, which is right here, and here's the critical. So yeah, the obtained is 6.9 and the critical is 9.2, which is less than. The p-value, which is right here, it is larger than the alpha because it's 0.03 and the alpha is only 0.01. And then that means the null hypothesis will be rejected and that there will be no sufficient evidence. Now let's go on to a question like 7, right? Wait. Yeah, question like 7. So basically, the chi-square was larger than the critical chi-square, and the p-value was less than alpha, which means the hypothesis got rejected and there was no sufficient evidence, or there is sufficient evidence. And this would be for this graph right here. Somewhat afraid, urban, whatever. And that's right here. You can see my work right there. Is the one in the middle. So basically you use that to get use this information right here to fill that out.